Good afternoon, everybody. Please let me know if there are any technical problems before we get really started. I'm really glad to be back live coding again, live streaming code, however you want to put it. I'm really excited about today's stream as well. We have a special guest coming on later, and that is the ever awesome Quinn Wilton. Hey, Justin, welcome. And Quinn is going to work with me on some Rust code, and we're going to do something kind of out there, which is really fun. Um, but we'll kick it off with some Elixir. I I did allocate on my personal schedule twice the normal length. So if we go until 7:30 Central, we go until 7:30 Central. On the other hand, I think that there's not that many things to do on Hardhat, and we should be able to tackle those things pretty quickly. So I'm looking forward uh, to working through the last few things that we have to do on Hardhat, and then we can do some fun, non-serious code with Rust. So you may have noticed also I'm gradually figuring out how to do OBS. So we have the Twitch chat there on the side when I'm in full screen. Hey, Quinn, welcome. And then so when we'll be live coding, I won't have the chat in the way, um, but we should be able to have that when we're in full screen, and I'll be able to hopefully see what you all are talking about. And for the folks who are watching the recording, afterward, you'll be able to see some of the chat. Anyway, let's get started looking at some Elixir. So let me switch here. Okay. So last time, 2 weeks ago, by the way, I should mention that we didn't do one last week because on that weekend it was my wife's birthday and also my parents' anniversary. So we did some family stuff. But the last time, which was 2 weeks ago, that we had a session, we fixed our timeout tests, which were, if I recall correctly, really interesting to figure out. And then we added deadline to Hardhat. So um, today I want to try to get the last two things. I feel like uh, adding regulator, which is the second bullet point here, it might be kind of a stretch, but partly because retries can be really, really tricky to get right and to make, have sensible defaults. So we'll see how we do on that. And if we do get to that, maybe what we'll get is some option to switch between using regulator and fuse. I don't think that they will work well together, which is why I say that. But maybe we'll be able to get something like a compile time switch that you can choose regulator instead of fuse. Okay, cool. So if you have any questions, this is your first time to the stream. Let me give you a brief overview of what Hardhat is. You can find it on GitHub at seancribb/hardhat. Um, and we've been building this over, I guess this will be the sixth session, right? So this is an idea that I implemented at a previous job. For reasons that are immaterial to this stream, we were not able to uh, open source that code. And I found it really useful at that job. We were doing a lot of calls to third party services as well as internal services, and people were kind of hodgepodge in what they picked in terms of both the HTTP client and then the sorts of resilience techniques that they added around those. And we really wanted to make sure that certain sorts of operational problems didn't crop up. Big ones being, they use the same connection pool for all things that they were calling, and so if you got a whole lot of traffic, some of your services that you were trying to call would be starved of connections, and then there were all sorts of other things related to just not handling failure well. So over the past 5 sessions and today into the sixth, we've been hooking together all these resilience techniques that you would put into a production system, and it'll be ready out of the box as an HTTP client. This is not going to cover everything that you want to do to make your services resilient, but the at least your calls to your internal services, if you got a microservices architecture or whatever, or to third-party services if you're doing a lot of integration with software as a service products, like we were. And then you'll have a bit of reliability built in, and you just have to tweak the knobs. So, okay, so let's look at what we have last. So we have automatic retries, and let's get into it. Now, I have, since last time, at Quinn's urging, actually, and thank you, Quinn, for doing that, I've switched to Z preview. So we're no longer on the stable Z release, but it does allow some of the things that we're going to do later, which I'm really excited about. And also we've, since it's been a couple of weeks, you remember a couple streams ago we set up Dependabot, and now Dependabot is sending me pull requests whenever anything is updated. So we've had to pull down the latest. And all right, so retries. What I want to look at first is let's look at the Tesla docs on Hex docs, because Tesla comes with a built-in retry middleware. Okay, so here we go. Where is it? Error handling, retry. Now remember, we did in our previous one of our previous sessions, we implemented our own timeout middleware, and part of that was having to do with that we needed to propagate state that the Tesla middleware was not going to propagate for us. And we also wanted to have a hook where if the timeout was exceeded, that we could add a annotation like on an open telemetry span. Hi, Chris Biscardi, welcome to the stream! Yay, Chris is awesome, and hopefully he'll enjoy our Rust section and give me plenty of feedback. Okay, so Tesla middleware retry, it uses exponential backoff and jitter. This is the main thing I was concerned about, is did it do jitter? I don't know if I had explained this previously, but we'll get into it hopefully when we get to talking about how to tweak this. We can see by default, this middleware only retries in the case of connection errors. So we're talking about things that will be POSIX errors. It'll be like error whatever from the adapter, as opposed to, well, it got a response that it didn't expect. So we can customize that through should retry, just like we had should melt for the Fuse middleware. Okay. Back off optimizes for tight bounds on completing a request. Okay, so yeah, we should have a look at this. My guess is that this has changed since I last looked at it. But you can see here the sorts of knobs that we can turn on the built-in one is what the base delay is, how many retries, and what the max delay is. So yeah, let's have a look at that. There's also a jitter factor. Yeah, let's look at the source of this. And we have it here in the depths, so we'll just pull it up in Z. And that is really dark today. Okay, that's Tesla. Let's look at the middleware retry. Okay, there's those defaults. Jitter factor 0.2. So let's see how it does it. The array pattern. Okay, so it starts by creating some map that contains some things. And these are just validating the options. There's the should retry function defaulting to, is it an error? The jitter factor, and okay, looks like they're validating it needs to be between 0 and 1. I'm assuming this is like 20% jitter based on that needs to be between 0 and 1. Okay. Right. So So we can, what I'm guessing here is that this max retries, if that's 0, that means never retry. So just do it once, and if it fails, right. So that's that first clause here. Um, so that would be a nice way for people to be able to bypass it if they don't want, um, if they don't want to have retries added. I may have mentioned on previous streams it's gonna interact a little strangely with Fuse. So we'll have to be careful about, especially in our tests, how the circuit breaker is configured when we have retries on the outside of it. The other option might be to have retries on the inside, and I think that there can be arguments made for that. I think, though, if we're going to go and possibly include higher level errors, not just POSIX errors, but things like um, internal server error responses or 429 responses where there are too many requests. If we want to put those into our possible retry conditions, then it might make sense to have it on the outside. Okay, so this jumps into this retry function, which is tail recursive. And in the case where there's no more retries, it just runs it, and then whatever the result is from that gets returned. Okay. If we're on our last retry, then just run and don't handle the error. Right. Okay. So if there's 0 retries max, then it's a no op. If we've hit the maximum, then also it's just do the same thing and return whatever the result of that is. Otherwise, it tries to run it. Okay, and if the should retry function that it put in this context map returns true, then it will try to do a backoff. So we'll go look at what backoff does, and it looks like they've made this much more sophisticated than last time I was in this code. Okay, and then it updates the retries in the context, adding 1. This update in function, if you haven't seen it, it's in the Elixir kernel module, which is auto imported, and that's sort of like a map.update, but it doesn't care about whether this is a map or a keyword list. Okay, and then it tries to retry again. Otherwise, if it shouldn't retry, then it just returns that result. So again here, if we hit the max retry, if we have no retries set, we hit the max retries, or if we shouldn't retry, then it's just going to return the latest run. Okay, let's look at the backoff function. Ooh, this is fun. Exponential backoff. Okay, so you're passing the cap. So what is the maximum delay, the base delay, how many attempts have been done, and the jitter factor. Okay, so those are all passed in for the context. I don't know why they didn't pass the whole context there, but whatever. Okay, so they're taking the attempt and they're shifting it left 1. So that's basically multiplying that factor by 2. I'm sorry, the number of attempts by 2. And then okay, so then it's taken the sleep time, the max sleep time is the minimum of the cap, so that's the max delay. So if you said you want to do exponential back off, so you're multiplying by a factor of 2 each time, how much to back off, then but you want a maximum like 5 seconds, which is their default. What they're saying here is that let's make sure that the base back off, the base delay, multiplied by the factor is never greater than that cap. Okay. Okay, so this ensures that the delay's order of magnitude is kept intact while still having some jitter, generates a value of x where 1 minus jitter factor is less than x is less than 1. Okay, so if our jitter factor is 0.2, that would mean that x needs to be between 0.8 and 1, according to this calculation. Okay, so here they're doing 1 minus Okay, so the jitter factor times RAM uniform. So that would put it between 0 and jitter factor. Okay. And then the actual delay is in the range of max sleep times 1 minus jitter factor less than delay. That's a max sleep. Okay. So this is some weird calculations. I'm curious also why they use timer sleep here instead of process sleep. I'm not sure. If anyone happens to know that, I would love to hear. Drop it in the chat. The reason why I would be concerned about timer sleep is that creates a timer on the OTP timer wheels rather than just putting the process to sleep. I don't know if there's any difference in terms of like precision when the process gets woken up from that sleep. Yeah. Hi, Sam. Welcome. Okay, and the rest of these are just validation functions for the options that are passed in. It's kind of a bit heavily factored there. Okay, so I think this is fine to use as is. My only question here is like some of this back off calculation. However, at this point, Tesla is so well adopted and well known that I'm feeling okay to trust them with this. So, all right, let's go and add retries. And I think this will follow a lot of the same stuff that we've been doing previously. There won't be that much to do except add it to the builder and then add some tests. So let's go ahead and do that. And yeah, so we're gonna do. And here's an interesting question. I think we need to do this. So this needs to be inside timeouts. Now deadline propagation is like, very minor. We did this in the last session. It basically just adds a header. So maybe it doesn't matter, but yeah, let's put it here. Where retry. And then we'll do something like this again. Retry ops. And this will let us both provide some defaults if we want to, or allow us to set them at runtime. Pull through the application configuration or something. So let's go ahead and put that in there. Now we're going to have to do something like this. So let's definitely add that. Defaults. So we have the defaults in there. And actually we may have to do something like this. So let's copy that. And we're going to rename this retry ops because I think that we want so fuse ops, this also had should melt, right? So we're going to do the same thing here like with the should melt. Should retry result, because it's not an env necessarily. Okay, and this allows us to pass in the module that will have this should retry function in it, right? Okay, so right, okay. Now we need to go over to Hardhat defaults and implement these. Okay. So it's going to be similar to fuse opt like we did before. Let's go ahead and put it down here. Make a doc string. default implementation of the options to Tesla middleware retry that is included in the default middleware stack. Okay. These defaults include... No, there it goes, suggesting alarm handler again. All right. I closed the Tesla docs here. Actually, I have them open in the browser. Okay, so these are the things that we need to implement. Okay, so I'm just going to dump those in here, and we'll annotate these options, and then we'll figure out what our defaults should be. And like, this is one area where I think in the previous implementation, I went back and forth with a lot of the teams that were using Hardhat about what the retries should be. We ended up setting the number of max retries really small. And partly that was so that, it was a liveness thing, right? We wanted to make sure we didn't wait too long. So if you had the max retries too high, say you retry like 10 times, well, with that exponential back off, you could go from, a round trip taking, 20 milliseconds to, oh, now I'm sleeping for 5 seconds. And that wasn't really that useful. So I think my inclination is to make this a bit smaller. But let's start with the defaults and maybe talk about why. So 50 milliseconds is fine as a base delay. Max retries, let's go ahead and say 3. Max delay. Now if you look at this, you're like, well, I'm never going to go over 150 milliseconds. But I think that we should double that, just because they're taking into account like that. There's that bit shift, right? So it's multiplying the retry count by 2 in the factor of what the back off should be. So should retry, we're doing mod dot and this is mod dot should retry 1, right? Yeah, the bit shift might send us over 150. So I think and like 300 milliseconds is still pretty tight if you're dealing with something that's flaky. But my tendency, like there's a line there for sure. You could go and have your tolerances be too tight and then like trigger so fast on the on the failure that you're like, well, that didn't even feel like a retry because you didn't wait long enough. The other way is that you can make it too big and then you're waiting forever for something that might have been successful in that long, delay. So this is a thing that, like at best, I'm going to leave that at the default. You can't decide for somebody for every case, and you have to look at the metrics and tune it. But yeah, thanks, Justin. Yeah, I think a 1/3 second is totally reasonable for a max delay. Okay, so we need to implement should retry, and there's another thing here that we can take into account because the retry is on the outside of our circuit breaker. We should test for this too. But we can look at if the error is blown, don't retry, because we know that fuse is just going to blow up. So that's a reasonable default that we can add. So we have to add that, otherwise it's going to complain about that function doesn't exist. Of the should retry callback. How did I do this on should melt? The melt test, yeah, okay. So let's copy this and we'll edit. That'll be easier. The retry test for retries will cause retries, will cause failed requests to be retried when, what did we say up there? I just deleted it. When the result of a request is. Okay. When the result will cause, I'm not going to put failed in here because like the definition of failed is very, very fuzzy. Okay, the function will cause, this function will cause request to be retried when the result of the request is, okay, so a TCP level error. Yeah, and these are actually fine, but it's important, I think, to put a note that in the case where the circuit breaker has been triggered, requests will not be retried. And this will prevent those sort of pathological situations where you have already triggered the circuit breaker and your retries just delay, expecting the circuit breaker to come back. I think that, obviously this is an opinion that we're making here, and it's totally reasonable to not do that. Am I indenting like that? No, okay. It's totally reasonable to go, well, you shouldn't retry when, oh, I forgot about this. We'll come back to that. Someone remind me later about 429. Too many requests. So I was saying, I don't remember what I was saying. Okay, so let's do should retry, and then we want to say error blown. This is that last case that we were talking about. Let's do that first. Yeah, remind me about 429. Thank you, Justin. Okay, so basically we're saying if the, because if you look back at the fuse middleware, or no, it says error unavailable. This is good that I looked this up. So it's error unavailable. We won't retry. Okay. Let's say that. Okay, so the other possibility of something that might interact strangely is if we have this keep original error, which I think we do on the defaults, that yeah, I think this is fine. It's just that there's no check here about whether this particular melt call caused the circuit breaker to blow. So, and we don't want to ask again in this middleware. Excuse me. So I think that, this particular return value is interesting. Might cause problems in the future. But can you put it into the EMD that the fuse did blow? Yeah, we could potentially do something like that. But the thing is, it's not like fuse melt returns anything useful. It's just a signal, and the triggering of it. Yeah, that's a good point. You might need your own fuse middleware, which we may get to eventually. I don't know that I want to do that right now. Maybe we'll do it in a future stream. But again, like fuse melt doesn't give us any useful information. It just says, "Hey, this was an error that I feel like is is a failure and should possibly trigger the circuit breaker if there's too many of them." Okay. Um, Circuit breakers are like, man, they're essential, but they are problematic at times. And I actually think that we should look at like I mentioned earlier, if we have time, we'll look at the regulator library having an AIMD strategy instead of a harder um, circuit breaker strategy. And then somebody can say, well, we'll never hit this case of error unavailable. You'll just get throttled, which is probably better. Um, anyway, okay, so if it's a error, and I want to look at the Erlang docs here. I think that there's, and let me bring that on screen. Sorry, folks. Um, I think there's something like POSIX. So there's these types in iNet. We've looked at this before, but I don't know if there's a way to say, is this a POSIX error? And we just have to rely on the fact that TCP is going to return one of these things. So like, if we get econ refused or reset or something, or enet unreach, yeah, it's so POSIX error codes. We could make a big. I'm not going to bother with that. Yikes. Because like I could make a big pattern match with that in a guard, but let's not. So let's just pattern match on that, and we'll say we should retry those kinds of errors. Okay, and then for the cases where we got a response, um, right, I think this will cover all the error cases. Okay, so let's make a body for this one. Um, so ENV, I'm going to put a pattern match in here so that it can help out the the code assist. Aha. Okay, so status. If it's 429, oh, and we can do it here. Tricky, tricky, tricky. We might not want to though. Remember I said ask me about 429. Okay, we'll just do what this says, and then we'll possibly look at 429. And actually, this is simpler. We don't need this if. We just need this expression. So we're only retrying in cases where the response was 429, too many requests, or there was a server error. Okay. I don't think I'm gonna. I mentioned this talking about 429 too many requests. What I was going to do here, and this also applies to, I think, some kinds of proxy responses. So if you've got a reverse proxy, be it like a CDN or something like Nginx or whatever between your client and the server that it's trying to call, there is a possibility that you, especially in this 429, which is an explicit back off response, it's saying, hey, you you're sending me too much. There is part of the spec, the HTTP spec, that servers can return a retry after header. So I thought what might be interesting is to look at the retry after header. And I think we did this at the one we did previously, but we had our own retry middleware, which is a copy pasta modify. But the retry after, and there are other signals you could look at too, depending on who you're calling. But that would give us an idea of like what our minimum delay should be. So we could feed that back into the retry mechanism, but I don't know that I want to do that today. That may be too much, and also it's kind of at the time I think it was specific to one of the third parties we were integrating with that we could actually take advantage of that. We could go. This is we know that they have a certain number of calls we can make in a certain amount of time, and when we run out of that, they're going to give us the retry after header, and then we can say, okay, well that's like, it's either, I don't remember whether it's supposed to be relative or an absolute timestamp, but we can stop this particular call and say, and like make it wait until that time. I think that could backfire on you because you could get thundering herd when that time expires, and then use up your rate limit again. So anyway, that was a little bit of a digression. Let's see if we can compile, see if there's anything broken. Okay, so because last time, or maybe it was the time before, we went ahead and made a default client, with this, you can see that we are, we aren't generating anything that's like, I don't know what that function is. Okay, so we have our retry policy. We have our default retry options. Let's go and test. And I think that this will probably look a little bit like the fuse test or the timeout test. Yeah. Okay, let's make a new file. Retry test. Okay. How did I name these? Was that just fuse test? Yeah, okay. So we'll do retry test. And we're going to use X unit case. And this will have to be async false. And partly because we're going to be interacting with the fuse. And then we'll use Hardhat in there. Hat, can I type? Okay. So the things we want to test is, and we might want to make additional clients with the, the overrides. Okay. That's an excellent point, Sam. Sam makes a point. If you get a retry header, how much would you take into account the other configurations, such as max delay? Evidently, you can still use jitter, just a jitter later than the retry after timestamp. Yeah, I think in that case you might want to factor it into the logic where if that retry after is going to cause you to exceed your max delay, then you should just fail. You should just return the current failed response. And not do any more retries. That's what I think I would do, because you don't want the delay to exceed that time bound. But that's sort of saying, well, the component that called this one has to deal with the fact that request failed now. So I don't know. A lot of these things are very contextual, and I don't know. I don't have good answers for them. Okay, So I'm going to have to copy this setup again. Do something like this. Right? Okay. And again, we will get, possibly in a future session, we will refactor this so we can have our own case templates that does some of this setup for us. Okay, so we need to, let's have a section on, yeah, that's a good point, Sam. Your calling function always has to deal with a fuse blowing or failing for all retries. Yep. Okay, so this is just a macro. This is testing the macro. So let's go ahead and do that. And we will copy pasta this and modify. Let's say retry options. Get in for Tesla middleware retry. Let's say retry. Okay, so remember that what this is doing is this is calling a function that the Tesla builder generates, and that comes from the stuff that we're doing here. So what we're looking for is what is the result of this call in when we are injecting those options. And I think this is something that is not, they don't make really obvious in the Tesla docs, but when you, and we're taking advantage of it here, but when you use this plug macro, this second argument to opts is double quoted. So, or rather, it's escaped. And then when it generates the middleware function, it unquotes it. So you get the actual call rather than, well, this is called at compile time, and then the result of that call is put into the middleware. So we're taking advantage of the fact that this is actually evaluated at runtime. And we are going to say, let's pick something here. We're going to fetch from there. What are some of the options that we put in here? Delay 50. That's a good one. Delay 50. Simple thing to test. Okay, so let's run that. Yeah, okay. I didn't expect that to fail. And basically, it's just a smoke test that our macro stuff is correct. Okay, so what other things were we tested in? So here we are testing what the should melt function does. Okay, so an interesting thing that we can do and we're going to have to look at this. Note here that, okay, so this had a smaller threshold on fuse. We might need to be concerned about whether we're going to blow the fuse. We wanted to put tight control on that when in our retries because the fuse is on the inside. Yeah, search should melt status. We did. Okay, yeah, we factored those out. Okay. So let's look at doing something like this. Default should retry. Now we could just construct something and pass it to that retry function. But I almost want to get something that's a bit more like a functional test. So I'm going to get, so our test is here. Let's look at defaults. right? Okay, let's hide that for a minute. Okay, so should not retry when the fuse is blown. What other things show? So should retry when there is a TCP level error. Okay. Should retry when, and this is like, let me reword these. Retries when the fuse is blown, or does not retry. Retry. Let's make sure that's correct. Retries when there's a TCP level error. Retries when the response is 429 too many requests. And I think that we should figure out how to detect the retries. I think that we'll probably do something like in the bypass, have it send messages to the test process. I think we did that in one of the other tests. Okay, and then we're going to do this for, 500 internal server error. Okay, and then we'll do it for, what is it? I think we tested this other one. Okay, we just said that blows the fuse. Okay, so I need to simplify my wording here. So let's do retries HTTP 429, and then we'll simplify that. HTTP 500, HTTP 501, and this is mostly just so that we can figure out what the commonality between these is in terms of the test pattern, then we can factor it out into a separate function. 502 and 503. I don't think that there's anything significant status codes above a 503, so we will have proved our point at that point. Okay, so what we're going to do here, so for this one, we don't need to set a bypass. And let's say for a second, I'm going to remove the split. Okay, so we don't need to set up bypass in this case because we don't care. I mean, maybe we need the data to like set the right URL, right? But we don't need to, it's never going to call it, because what we're going to do is we're going to trigger the fuse to be blown. Okay, and then it won't retry. So I think maybe what we should do is set up this expectation or stub bypass, and the method is get path is slash. And then it takes a plug con, right? And so plug.con respond connection status, status is 200. Hello world. Hello world. Okay. Now the thing is, we need to do some of the same stuff down below. So it might make sense to set this up as something we can reuse. But let's do it once first. Here it'd be parent self, Um, now, I could use I could use like a process. No, that won't work. I was gonna say I could use a process dictionary thing here to keep track of how many times this was called, but we actually in this case we don't expect it to be called at all. So what we're gonna do is just send parent um, request, and then eventually what we want to do is do refute receive request, because we don't want this to be called at all. We don't want that server to actually be called at all when the fuse is blown. Okay, so now let's blow the fuse. Circuit disable. And it's going to be test client, right? Because that's what we reset up here. So here we're doing fuse circuit disable. And we'll probably need to do fuse circuit enable test client. Just to make sure that we're resetting that state after each test. So here we're disabling the fuse. See if it has any docs on that. Nope. Woo, fun. All right. So we're going to do, let's do something like assert error unavailable, because this is what we're expecting out of the fuse when it's blown. Unavailable. And we'll do test client dot get localhost bypass dot port. Should be familiar at this point. Okay, let's run that test. Okay, so 8 tests, 7 failures. Okay, what we actually got was a response. So that's not correct. I'm guessing it has to do with the fuse there. So let's look at the docs for fuse. Yep. Let's just make a new hex docs. Fuse. Okay. So circuit disable, break the fuse, right, okay. Maintenance. And then that re-enables. So the problem here might be that the fuse was not installed when we called circuit disable. So what we need to do here is say this. We need to call it once so that the fuse is installed. Because remember, in the fuse middleware, it actually does the install if it's not set up correct already. And it uses those options that are there in the fuse options that we defined. So we have to have that fuse installed before we can disable it. Otherwise, this is a no op. Okay. And it still fails. Yay. Okay, so what did we get? Okay. So I think we're going to need to figure out, and we may fall back on our pal recon. Yeah. let's enable recon. That stack trace line number is sus. Let's see. Retry test 36. Okay. Line 36. Did I not save it? Let's run the test one more time. Okay, so in this case, we got. So what we want to do, instead of this refute receive, maybe we want to do, yeah, receive. So we actually got to the end there this time. Yeah, it's possible I just didn't save it. Thanks for calling that out, Sam. So here we did get the request, so we should have one in the mailbox. We shouldn't have two. Okay, so now it's not failing anymore. You can see a green dot there somewhere. Okay, so that's fine. Let's put bypass in here for this one. So this one we're going to do similar to the fuse, where we actually take down the bypass server. So we say bypass down, and that way we'll get like econ refused or whatever the appropriate TCP error is for when you can't connect. Okay, and then we're going to say, now this is going to be a little bit harder because we don't have what is a way that we could trick this? We could, I wonder if we can supply an adapter at call time. Not this. Let's look at Tesla. Because we might be able to supply something like similar to Tesla Mach, right? But where we give it, and then we can inject a TCP error. The main thing here is that what this isn't going to tell us anything if we fail every single time. It's not going to tell us that we retried, unless, and we should look back at the retry middleware again, that unless it says too many retries at failure time, but I think it just returned the result of the last one. So I don't know that we have a good answer. Maybe, you know, I started down this route, but I think that this is actually wrong. We need to do something else. Actually, I have an idea. Okay, so rather than bypass down, let's say bypass stub. And help me out here, code assist. What do we got to do? We did it up here. So what we're going to do here, rather than respond, we're going to send a message. So basically this. Let's copy all that. Come on. Okay, so we're going to send a message, and then we're going to exit. Boom. Now this is kind of dirty. It should not crash the bypass server, but it will crash the request process, right? Okay. So, um, and then we'll have to do something like at the end here, we'll say bypass pass. And then that way we don't get these exit booms in our test output as failures. We're just saying, hey, it passed if we got to this point, because we're expecting some failure. Okay, so we should do uh, and then so this will be the error, and maybe we'll look at what this is. Um, let's say call it POSIX because that's what it's going to be. Test client.get should be localhost bypass.port. Okay, so we're going to make the request with retries. And then what we're going to do is because we expect 3 tries, right? We're going to say assert receive request. So we should receive 4 or 3 messages there. This is there's probably a one off by 1 error in here, but let's run the test and find out, because I think that this should give us what we want in terms of, yeah, it's going to close the connection without responding. The only possible other result here is that Cowboy, which is running inside bypass, Cowboy, the HTTP server detects that the request failed, or that the request process exited, and responds with 500. But let's just IO inspect POSIX. I want to see what this error is. Pew pew pew. Yeah. Okay. So let's get this up. Come on. There we go. Yeah. Okay. So we got some crashes. The thing is here. So yeah, this is what I suspected might happen. It's giving us a 500. You can see here that it's exiting on those. It actually gets called 4 times, not 3. But we're getting a 500, so that's not going to work. Okay. So interestingly, I think that we have. Yeah, let's not do this. Instead, I think we're going to do the idea of a custom adapter. So let's make a custom adapter here. And that just takes an env and returns an env, right? Or returns an OK result. Oh, seriously? Come on. Okay. So our adapter is going to be, basically it's just going to return econ refused. And then let's make, so here we're going to get, and we can leave this in here, but what we're going to do is let's figure out how to construct a client. Oops. Don't want that. I want that. Tesla. So we want to construct a client here. Where we supply the adapter. So build client, that's deprecated. Right. So we're going to build a client. And we're going to give it, empty middleware, and we're going to give it our custom adapter. So this adapter has to be a module, or a module and some options, or a function. Okay. So we can do that. And then we'll put it as the first argument. So this is a better way And then we can do, we'll keep this in here. And we'll say send parent, even though parent is probably self at this point, just in case it's not, we'll do this. And then we can say client is Tesla dot client, and we pass it empty middleware and adapter. And then we'll give it, so this is just a hack to say we're not going to use Finch for the adapter. We're going to interpose, and then we should get con refused. And we probably don't need to do that because there's no assertions made. Okay, let's try this. Is anyone confused about what's going on here? Say it in the chat. In the meantime, I'm going to open up the shell here and see if we can run that test. Okay, we're down a failure. Yeah, so let's fix that warning real quick. So basically what we said here is we're making a custom adapter so that we don't actually go and try to establish TCP connections and make a call to the bypass server, which we're going to make crash and return 500 instead of returning no response. So here we're just saying, well, we pretend like we're the network stack, and we're going to return this TCP error. And then, because we are sending the test process this request atom, then we should get 3 or 4 of them. Actually, 4, yeah. Max retries, not max tries. That's the thing that always gets me. It's a one-off, right? So we should get 4 of those in our inbox. Okay, and then we can do something similar to this, this pattern, and let's for all these status codes. So. Okay, and then let's do this once, and then we'll factor it out into a function, and we'll repeat it for each of those status codes. So it's going to be very similar to this. Except it's not going to be concerned with the fuse. Okay, and here we're going to, instead of 200, we're going to say 429. Okay. And then we're going to do assert OK env is test client.get, and just I've typed this too many dang times today already. Okay, so we are going to get a response, but it's not going to be one that we wanted to get. So then we'll do env.status equals 429, right? And then we'll do our little loop here. Okay, so now we've done one. Let's pull out the important parts, which is most of it, into a function. Assert retry status code. And we need the bypass, and we need the status code, right? Let's copy that into here. And all the places, so bypass we don't need to change. All the places that this is, we'll put the status code. Okay, and then we can slurp that out and go assert retries status code bypass 429. And I think like in the original implementation, I probably did some like loop over the status codes that I cared about rather than having individual tests, but you get into macro land too much and it can be kind of a pain. So I'm not going to do that today. We're just going to get the rest of these status codes copy pasted in. Oops. .502 and 503. Okay, and let's do a little formatting. I think that's pretty much. I mean, we could go farther and test the things that Tesla middleware retry tests, but I don't really feel like that's useful because they've already covered it. What we want to cover here is what did we change about it? We changed how it interacts with certain kinds of responses, and we changed what the default retry options are. So I think that this should be sufficient to cover. And let's run all those tests again. Hopefully we get all greens. Now notice they're a little bit slower because we got delays in there, right? It is delaying a little bit, and it's also not async because we have to be concerned about blowing the fuse. Okay, let's make a commit. I think this is pretty good. And actually, I wanna unstage mix.exs. We didn't actually use recon. Yeah, let's not. Okay. And let's look at the change. So we have the should retry. It delegates to the defaults module, and here we are passing in the module of the client, and they can override this if they want. And then we adding the retry middleware there above fuse. So there is this is fine. Let's make sure those docs are correct because we actually have a difference there. I think those docs are not correct. Right. Oops. Command J. Because we changed this from 5 to 3. So let's say that's 3. It defaults to. I don't know how they expect. Maybe it's just the exponential factor there. I don't know how they expect it to go up to 5 seconds. That's wild. Okay. And let's say it defaults to because that's in this module. We can help out on the docs there. Okay. Yep. Okay. So should retry result Hardhat defaults. Okay, so we've got the middleware in there. We have the implementation of the retry options that are defaults. We have the implementation of should retry. And then we have our test. And just for sanity's sake, let's run mixed test again. Make sure nothing else broke because, you know, those things we added could interact. Aha! So I figured this might happen. Notice all of our tests in the fuse test broke, right? Because we retried and then we ended up blowing the fuse. Or something. I'm not sure what happened there actually. But I think we should probably fix the fuse test and put a note about it. I mentioned this at the beginning of the stream and I just trolled myself. Let's not retry in test. So we're going to say retry ops, right? And it's going to say, yeah, it never hurts to prove it works. Yep, max retry is 0, and then uh, we will never retry, right? So let's see if that fixes the test. Um, if it doesn't, then I'm not sure what broke. We'll have to dig into it. Hmm. Okay. Write a breaking test first or something. Yeah, Andy, I'm too lazy for that. I write the code first, then write the test that I think should exercise the code. um, okay, so let's see if we can isolate the fuse test, um, and see if it still fails on its own without the other things. Oh, you know what we didn't do? This is good. This is good because what we didn't do in the builder is put def overwritable, right? So we need to override fuse ops or retry ops 0 and should retry 1. Since they weren't overridable, then we weren't going to be able to um, change them in that test. Let's try it again. Okay, yeah. Yeah. So, lesson learned, I think. Retries can interact oddly with circuit breakers. Lesson to take home, kids. Okay. Let's look at our change now. So now we've got the overridable on that function. So the user can override should retry, and they can override retry ops. Okay, and then we have the default implementations, and then we've got our note here in the fuse test to not retry. And then we've got our retry test that we added. And just for good measure, let's mix format. Cargo's messing me up there. They use FMT for whatever reason. Okay, so we're going to add retry middleware to the default stack. Cool. That was pretty good. Now, what do we have on our agenda? We did retries. I think let's make sure that why did that open in a new window? So I need to save that. Let's commit amend. Oh, because that's, yeah, I understand why. Sorry. Because we added retries, they should be listed in the README. Okay, so I'll take a pause real quick for any questions. And then we'll possibly look at regulator. Okay. All right, there aren't really any questions right now, so let's look at Elixir Tonic org again. Yet again. I think this is there, and it's not in Keithley's. Yep, there it is. Okay. All right. So, what is regulator? Regulator is an alternative to circuit breakers in a way. Um, it has several strategies, but basically it's a concurrency control. Um, and so the use case that we're thinking of, because this is client side, you would do something different on the server side, but rather than trying to determine, what is like a hard break point for failures, um, and how often should you try again? Like when do you stop, considering the thing failed, and just test again, which is sort of what Fuse does. It has the how many failures in this amount of time to blow the fuse, and then how long should I wait before I reset the fuse. Regular instead says, well, we don't know what the capacity of the thing is, um, and so let's just figure it out as we go. And this is basically the same as TCP congestion control. So that's the AIMD, the additive increase multiplicative decrease. And we'll need to look at this one option that it provides. Yeah, so you can think of it as an adaptive dynamic circuit breaker. So rather than saying I have a harsh limit on how many failures I'll tolerate, it's well, when I detect failures, I'm going to throttle. So you essentially achieve the same thing, um, but it has a token bucket. It tracks how many things are ongoing, um, and then so you can see here, for example, excuse me. So we do regulator install on this type of regulator. Again, we'll have to look at what this timeout means. But then you can do something inside this regulator ask, behind this guard. And then if there are too many of these going on, the regular ask will return something that indicates we don't have that capacity. But if it hasn't detected errors recently, it'll go, okay, let's add another one. Okay, so there's a lot of text here that I'm not going to read, but what we can do is something like, let's make a middleware that does ask with whatever the name of our regulator is, and if we get a token from the regulator, then we call Tesla run. If that succeeds, then we can, if we get an okay response, and this is similar, we should consider, like, maybe we can reuse should melt. I don't know. And then we'll say regulator okay and give it the token if it was fine. If it wasn't, then we can say regulator error. And so that kind of tells the regulator, I encountered an error that might indicate we should back off. And then the other option is if this would be dropped because we're over capacity, then you can do something else. So, and this would be similar to when we get fuse blown in our other middleware. Okay, so AMD, this is the one we'll probably use. Gradient limit algorithm is very interesting, but I don't think will apply for us on the client side. That's probably more like you need to track server side statistics and give some back off if you see the trend going down, or getting worse. So I think that we'll give this a try, and I don't know if I don't know what we'll discover on this, and it's going to be interesting to test as well. Real quick, let's look at the code, and then in maybe about 20-25 minutes, if we get that far, we will take a break, and I'll bring Quinn on and we'll write some Rust. Okay, so regulator is its own application. Um, Basically, install creates, it spawns a process that manages that limiter. Okay, and so let's look at what's down in here. We don't really need to care about this stuff too much, although telemetry might be interesting, something that we want to let people know about. Okay. So let's look at AIMD. So loss-based dynamic limit algorithm. There's some flags on it. Of course there are options. Of course. So there's a minimum limit of concurrency. So that's like what is the bottom? So if you're backing off because there are errors, what is the bottom limit? The initial limit is what do you think is a healthy starting state? So like in TCP, this might be your initial window size, right? Um, and then the max limit. This is what you want to top out at. Okay, and the step increase. So we're gonna have some tunables here. There's a lot. The back off ratio. So this backs off really aggressively. So 0.9. So it's like backing off 90%. If I'm understanding this, we'll have a look and make sure that that's correct. Okay, so the timeout / target average latency. So the average latency milliseconds this for the system regulator is protecting. So if the average latency drifts above this, regulator considers it an error and backs off. Okay, so this is like you have this defaults to 5 in 5 milliseconds. That's really low. Okay. Okay, so this is a way to tell it basically the time between when you ask and when you say okay or error. If that gets too big, then it's going to consider it an error. Yeah. Okay. So if we've dropped a request or the average round trip time is greater than the timeout, we back off. Okay. If we're halfway to the current limit, go ahead and increase the limit. Okay, so that's making sure that you don't hit the ceiling before you're able to increase the number of tokens. For the max limit, reset to 50% of the maximum limit. Okay. There's some math here I don't fully understand. I thought it was going to be simpler than that. That's okay. I think we could look at some of these others, but I'm not really that interested in it. I think let's throw this in there, and maybe figure out how we can make it optional, or make it flip between, what are the fuse options versus what are the regulator options. So we would be able to say, you can select which one. We're gonna have to think about how to do that. Okay. All right, let's start by making a middleware regulator. Oof. Okay. behavior Tesla.middleware, and we'll do this. Okay, and then let's look at the examples and basically just implement their example. So, and we'll figure out what we have to fill in from there. Okay, so I'm talking about this example, right? So what we're going to do, let's add regulator to our dependencies. Let's see, we just guess 0.5. Cool. Okay. Okay. And then we'll deps get. Okay, so we got regulator. And so now we want to look at, so we'll expect that the options will be passed in here. I wonder if there's a way to tell if it's been installed. Let's look at the API. So we ask, right? Fine. Yeah, I think we have to know. Let's see. Look at the application. Yeah, it just starts this dynamic supervisor. And then there's this, yeah, one-for-one dynamic supervisor. So what I'm wondering here is, can we know if it's been installed yet? And I guess we could say, let's look at dynamic supervisor, because I think that if it says that it's already started, start child, yeah, on start child. So it could say error already started. We could do, I don't really want to call which children on every call. Let's think about this. Because similar to Fuse, this has, this resource that has to be started before we can take a look at it, before we can ask it to do anything, right? So we need to find where it should be started. Now with Fuse, the Tesla middleware here, where is it? So if we look at the source real quick, um, Fuse will return error not found if the named circuit breaker doesn't exist, right? So I think like this is says, well, I can call Fuse install now with my options and then try this again. Um, but in our case with regulator, the regulator is a process, not an entry in an ets table. So, um, the question in my mind is, does this register a name? Because if it does, then we can use process where it, yeah, I bet it's this. It just registers a name. So the other thing that we need to think about is that over here, our child spec registers this name for so we can't use the name of the client module as the name of the regulator. We're going to have to give it another name. Okay. So so let's just assume for now that it has been created, right? So we'll say, or that name, and let's just say the regulator name is going to be env.module. We'll say like module concat. Yep. Regulator. And I think that's how that works. Yep. Okay, so this returns a new alias. Okay, so that'll give us the name of the regulator we expect. And we can say process dot where is reg name, and this will return a PID or nil. Why are you doing that to me? Okay, so if it's nil, then we want to we want to install it. So okay, so this isn't as bad as I thought. And then we're going to do regulator dot limit dot AMD, and we will pass the opts here. So we're basically deciding that whatever the options are passed to this middleware are the ones for installation. Okay, so let me put a note here. Ensure that the regulator is installed. And you know, this constructing a process name and doing process where is going to be a lot cheaper than calling the dynamic supervisor to figure out whether it has a child of that name. So just with the assumption that, you know, given we saw in here for uninstall they do process where is, then we also can use process where is, and we know that's a BIF. That's really cheap. Sorry if you don't know BIF, not the character from Back to the Future. It's built-in function. Okay, so then the next step is regulator dot ask and our name, right? McFly. Okay, so let's go back to their example. Okay, so you do ask, and if you get a token, then you can go Tesla, let's say result, Tesla.run, env next, and then we can go if we might have to do some, right? Let's think about this. Let's call it should regulate. Then we will say regulator dot error token. Okay, and then we return result. And then the other option here they say is dropped, right? And in which case we should return something like we should return something like error unavailable, just like we did with fuse. I'm not real happy with this. And I think this might have a problem. We need to validate some of our options up here, obviously. I have a feeling that regulator, I mean, I saw the norm dependency get pulled in. It probably has, it probably uses norm to validate, but I'm not seeing it. Is it here? No, that's just the limits. Nope. Hey, it uses ETS tables too. Okay. So we need to figure out what it actually spawns. Oh, right. It's a limiter soup. Okay. It's a monitor limit calculator. Okay. Right, and it's using ops name here, so it's registering that name. Okay. Let's look back at this. Right, okay. So this mod new is the limiter that we wanted to use. It's this. So okay, so if you pass it options that it doesn't accept, we're gonna have to pull off our should regulate function anyway. So that's kind of what I was trying to get at, and we're gonna put a dot in there. So should regulate is keyword dot pop we can do this with the default. Ops should regulate. And then the default is going to be env.module. Nope, module please. Dot should regulate 1. Okay. So, excuse me. You know what? Let's not put a default there. Let's just let it blow up. Let's let it crash in this case, because we should be. Keyword pop. We probably want something different here. So pop that require. Oh, I see. Okay. So what we need to do is we need to do should regulate ops. And then the rest of these options can be for the regulator. And so we took off the function that, yep, the function that we use to be our gate of deciding whether it was good or not. Okay, so this is, you know, not that different from Fuse. We just need to go and provide the options correctly. So let's do that, and we can use the defaults from regulator. At this point, I don't really have strong opinions about them, except for maybe some of them are really tight. But we can provide those, and then and provide a should regulate function, which is basically the same as should melt, and then move on about our lives. So yeah, let's go ahead and go here in the defaults, and we'll make a new one. So this is going to be regulator ops. We'll just follow our current pattern that we've been doing so far. And reminding me to put a doc here is good. Okay, so we're gonna do this, and then we're gonna do should regulate is gonna be mod, and this is provide the closure there. Can I type? Okay. And I don't know if there's, yeah, let's just slurp the defaults in here from regulator. Default options for the regulator middleware, which can be used as an alternative circuit breaking strategy to Fuse. And let's see. The defaults include. Boy, it really loves inserting alarm handler for me. And yet, I don't care about alarm handler. Okay, and so I'm gonna remove this. We don't care about that alias. And then we're gonna say should regulate whether to consider the result of the request as failed, defaults to should regulate. Okay, and then I'm going to copy pasta because I'm feeling lazy. This, and we'll put it down here, and we'll say we'll rename it should regulate. Because honestly, it's the same behavior, but what I wouldn't want to happen is someone follows this pattern and then all of a sudden, well, we're calling should melt instead of should regulate for this different middleware. So melt test for dynamic regulation, the failure test. Okay, we'll cause the regulator. Let's keep linking to that. To record an error when the result of the request is yada yada. Okay, so and now let's do all that plumbing again. So over in Builder, we have something similar to this. Yeah. We're gonna dock false again. Def regulator ops. Okay. Okay, def delegate should regulate result to Hardhat defaults. Okay. And then we need to have regulator ops 0 and should regulate as overridable. And I think that when we get to having plumbed this in, because I think the macro is going to be harder, I think I'm going to leave this without a test for today, because I want to switch gears and have a break as well pretty soon. Okay, so let's see here. So we need to do something with the ops that we're getting in from our using macro. And this will be the first time that we have used it. The other possibility is that we make a module attribute that says what the circuit breaking strategy should be. What do people feel like about that? Because in some ways I want to say it's probably better to do it in the using macro. So that would be like here we say use Hardhat or use hardhat.builder. We're going to have something decided at that point. I think we should do that. So, the question in my mind is, we need to be careful about what the contents of this is. So, I think we need to document what it should be. So what would we like that to be? Just to something like use Hardhat. We could say something like strategy fuse, like that, or or regulator, um, or we could say it could be circuit breaker. I don't know about circuit breaker, whether that's like too. I don't know. Does anyone have any opinions on that? I feel like it should be this, this option when you put use Hardhat in your thing. Um, so okay, so let's start by saying let's IO inspect ops here. I'm going to be lazy, and then we're gonna compile this a couple times. So um, yeah, suspend strategy. You're not really suspending though. Um, maybe I don't know. Like circuit breaker describes kind of what it is, but um, the other thing is I don't want to use to introduce too many new words that are going to be too different from the things that we already have in there. So um, yeah. All right. So what I'm going to do here is I'm going to say let's just put in some bogus stuff here. Strategy regulator like that. And what I want to see when we compile it is what the output of that is. Oops, what did I do here? Line 10. What did I mess up? Undefined variable falls at line 10 of Hardhat? What? Did I do something? What did I do? That is the weirdest. I don't see. Okay, because I'm guessing this is in the macro. That let's try it one more time. Yeah. Okay. Hardhat builder. There's something that's saying falls without. You said line 37. Oh, doc false. Thank you. Wow. Wow. Thank you, Sam. This is why I get you guys on the stream, is you can keep me honest. Okay, so it when it's a simple keyword list like this, the compiler's not going to escape that. If it had something more complicated in it, it might escape it. Um, so like if I did, let's see, if I made this like this, it's probably going to blow up for other reasons, but yeah, see, it escaped that. Um, so we need to make sure it's keywords. Okay. Okay. So I think, I don't know. I feel like strategy is okay. Um, but the main thing we want to do here is capture this option as it's coming in, um, and maybe make our own. Yeah, I think we're gonna have to use a module, like an at a module attribute. That's what I'm going for. Okay, so I think what I want to do is, let's say, case keyword get and let's say let's just call it strategy. So the fuse regulator. And then anything else, let's say invalid. Arrays invalid. Option invalid. Strategy inspect invalid. Yeah, I don't know that this is real great. No. I'm doing this wrong. We want a default here. Let's default to fuse, right? I think that there's a 3-arity. Yep. So the default is nil, fuse. Otherwise, yeah. Okay, so now we have a strategy, and we can put that in here. So let's say let's make it kind of hidden or something. I don't know if you're allowed to have leading underscores on module attributes, but we'll find out. So let's call it strategy. And I think it's unquote. Unquote strategy, right? Because we need to make that hole in there. And it's not keywords, it's ops, and we want the key is strategy. Okay. Now we could make it so that we like put the default in here, and we allow the user to override it, but we also want to make sure that it has a valid value. I think so. I think having this way is fine. Hi Keenan. Do I know anything about reverse engineering? Not specifically. No, I think you might be in the wrong stream. Okay, so now what we want to do is down here in our before compile. So this will happen. Remember, this happens after the user has specified all of their middleware and all their definitions. We tack this onto the end so that we get everything in there that we want in the default stack. What I want to do is parameterize this. So we need to look at what this env thing is. And I think it has to do with modules. So if we jump to before compile, let's see. They talk about it down here somewhere. Compile callbacks. Okay, but a hook will be invoked before the module is compiled. Okay, so the env, that's not that useful. It is. Sorry, I'm futzing with the search here. We want to find this struct. Oh, that's fun. Oh, no, it's not module env, it's macro env. Yep. Okay. So this is going to tell us so we'll have the current module name in here, right? So what we want to do is on that do module get attribute. I believe it is. Okay. We're almost there. We're in the home stretch, folks. Bear with me. Okay, so we want to do strategy module get attribute env.module and strategy. So that is the module attribute that we registered in the using. So let's just do case on that. And if that is fuse, then we want, so this is going to be CB middleware, right? CB ops. Okay, so if it's fuse, what we want to return here is Tesla. Hello. Middleware fuse. And we want to quote module fuse ops. I'm not sure that this is exactly going to work the way I want to, but let's go with it for now. Regulator, and then we'll do quote module regulator ops. Okay, so this just lets us select which one we're going to use here. Right? Okay. Oh, I'm sorry. Do requires a do, even if you're just inlining it. Okay, and then we're going to go down here and we're going to say unquote. And I think this will work because this one, you know, the unquote of an atom, of a bare atom, which is module names are atoms, is the same thing. So there's nothing to be concerned about there. CB middleware. And then here we'll unquote. And I hope that what we don't get is double quoting. But I think we'll be okay. This is a fairly. Now we could do. No, we don't want to escape. I'm sorry. We don't want a macro escape. The other option we could do, and this might even be better. Yeah, I kind of this. Let's say circuit breaker. Let's make it an actual quote of the whole thing. That makes me feel a little bit better about understanding it. And then here it's quote do, and we're not concerned about whether the how this will interact with the options there. So that's basically what we had before, right? And then for this one, we'll do something similar, but with the different middleware. And then we won't have this concern about whether it's a double quote or not. It'll just work in the same context because it's a quote of the whole expression, and then we unquote it in place. Okay. I suspect this is going to blow things up. Yeah. Let's find out. Oh, it worked. So, to see what happened, so remember over here we have no strategy. Up here we were checking for that option. Okay. Yeah, so actually I feel like we maybe should have a builder test at some point, and we'll test this thing. I want to just test it by hand right now. So let's say strategy is bogus, and we should get a compile error. In fact, yep, invalid strategy, bogus. Yep, I thought so. Hello. Okay. Having Command J and Command H right next to each other is not fun. So if we say strategy fuse, it should compile. And let's do mix decompile to expanded Hardhat. Okay, and then we're going to look at Hardhat, elixir.hardhat.ex. By the way, if you don't know about mix decompile, when you're writing macros, it is your friend. So we're going to look for middleware. Okay, so we can see there, yep, that looks correct. That looks like what we had before. Let's play it again, Sam, but with a different, so let's use the regulator strategy. Oops, that's not going to do anything. Hello? Okay. Mix compile. And let's look at middleware again. Okay, so now you can see we have regulator in there. I think that is a pretty good place to stop. I am not going to make a commit on this. I want to take a 5 or 10 minute break, and then we'll bring on Quinn, and we'll do some Rust. So go get yourself a drink, get a bathroom break, and we'll continue after the break.